Hello students. Now in this video let us start the measures of dispersion, that is our chapter 3 of statistics, measures of dispersion. Measures of dispersion. Now first of all let us see why does it need the introduction part of this. Now there are various measures of central tendencies give a single figure that represents the entire data. But the average alone cannot adequately describe a set of observations unless all the observations are same. Now for this let me take an example. Suppose I have an example. Suppose I have three series. Series A with the observations 50, 50, 50, 50 and 50. And series B with observations 20, 25, 50, 75 and 80. Now suppose series C is next one, having the observations 5, 10, 75, 150 and 10. Now if we are going for calculating the mean of these series, we get that the mean of all of these three series is nothing but the 50. But you can see here these are what different series, or the observations are also what the different. Hence it is necessary to describe the variability or the dispersion of observations, and the different sets of observations may have the same central value but they differ drastically in their constitution or according to the observation, we can say. Hence I can write here, this is what an introduction we are giving for the dispersion. Why does it need? Now this is not required to write down, but just for your understanding I am giving this. So I can write here that the property of items, in the given data, to differ from each other is described as, or is described as the dispersion. Or it is also known as variation. It is what also known as a variation. Now the values which measure this tendency of observation, okay, to differ from the values which measure this tendency of observations to differ from each other is called a measure of dispersion. And the same one we have to see in this chapter, the measure of dispersion. This is an introduction for this. Now why does we need this measure of good measure of dispersion. So let me take that one as an requirement of a good measure of dispersion. The requirement of good measure of dispersion is that a good measure of dispersion, should possess as far as the following properties, or the following properties. Should possess the following properties. Now what are the properties? So the first one, it should be simple. It should be simple to understand and calculate. Simple to understand and we can say easy to calculate. Everybody should able to calculate it and able to understand it easily. Okay. Then the second one is that it should be rigidly defined. Rigidly defined means what? It is same everywhere. That is, it is rigidly defined. Now it should be based on all the observations of the data. Fine. It should be this. All the observations of the data. Then the next one, it should be capable. For further algebraic treatment. It should be capable for further algebraic treatment. Then the next one, it should be least affected. It should be least affected by sampling. It should be least affected by sampling fluctuations. Then the next one, it should not be unduly affected by extreme observations. These are some properties that are required to satisfy for good measure of dispersion. So for this purpose, we need the measures of dispersion to calculate. Now, there are two different measures of dispersion are there. Actually, there are many of them, but mainly there are two, that are absolute and relative measure of dispersion. So let us see that one. Now here, let us see first what is the absolute measure of dispersion. Let us see that one first. So actually the absolute measure of dispersion is what? The measures like range, variance, standard deviation, etc., etc. Measure measure the magnitude of dispersion, and hence are the appropriate units of dispersion. They are called the measures of absolute dispersion. They are called the measures of absolute dispersion. Now these are useful for comparison of variability of different data sets only when they are in same units. That is very important. They should be in same units. Then we can do that. Fine. Now they are in same units. Now let us see the another one. That is what? The relative measure of dispersion. Now what does this relative measure of dispersion? Actually, measures of dispersion are independent of units and can be used for comparison of variability even when the data sets are of different sizes and different units also. Now, such measures are obtained by taking ratio of measures of dispersion and some central value of the data. What can we say? The measures of dispersion which are independent of units and can be used for comparison of variability even when the data sets are of different sizes and in different units. They are in different sizes and in different units. Such measures are obtained by taking ratio. Such measures are obtained by taking ratio of the measure of dispersion and some central value of the data. Hence are called, as it is a ratio, hence are called relative measures of dispersion. Now, the very best example of relative measure of dispersion is that coefficient is what? Coefficient of variation. Now, here in this chapter, which measures of dispersion we have to learn? So, the measures of dispersion we have to learn are the range, quartile deviation and standard deviation. Basically, these three measures of dispersion we have to learn here. Which one? Now, what can I write? According to our syllabus, I must write, we have to learn the measures of dispersions are, which are they? The first one is what? Range. This is range. Second one is quartile deviation. And the third one is what? Standard deviation. These one we have to learn here. Fine. Now, these measures have the same unit as those of observation. For example, the data is given in degrees, in centimeter and minute, etc. And the measures are called the absolute measure of dispersion. These are the examples of what? Absolute measures of dispersion, as we saw earlier. Now, let us start the range. Let us start first the range. Now, what is range? It is the simplest measure. Measures and suitable if the extent of variation is small. Now, observations, it is a very measure. Now, how does it define? It is defined as difference between between, defined as the difference between the maximum and the minimum values of the data. Maximum and minimum values in the data. Maximum and minimum values in the data. Now, how to compute this? So, let us see computation of range. Computation of range. Now, here in computation of range, first of all, let us see for individual observations. For individual observations. For individual observations. So, in this one, actually, if x1, x2, so on up to xn are n observations, on the variable x, on the variable x, suppose, then the range is what? Then the range is given by, what is the result? The range equal to this x maximum value of x minus minimum value of x. Here x maximum is what? Maximum value is maximum value of x in the data. Value of the x in the data, and minimum is what? The minimum value of x in the data. Minimum value of x in the data. Fine. This is a way for to determine the range for individual observation. This is very easy. Now, let us see for grouped frequency distribution. What is the way to compute the range? In grouped frequency distribution, first of all, we have to obtain, the first step is that obtain class boundaries. Obtain class boundaries. Then second step, obtain mid values of first and last class interval. First and last class interval. Mid values of first and last interval. Now the range is the difference between the largest and the smallest mid value and the smallest mid value, or between upper class boundary of the highest class, upper class boundary of the highest class, and the lower class boundary and the lower class boundary of the lowest class. This is our way to find range for grouped frequency distribution. Now, what is relative measure of dispersion here? Relative measure of dispersion. Relative measure of dispersion is nothing but the coefficient of range. Coefficient of range. What is this? This is x maximum minus x minimum upon x maximum plus x minimum. This is relative measure of dispersion here. Sometimes it is also asked to determine. Now let us see the merits and demerits of range. Here the merits and demerits of range. Merits and demerits of range. Now let us see first the merits. What are the merits? Now the first thing, among all the measures of dispersion, range is the simplest. Range is the simplest to understand. And easy to calculate. Okay. Now the next one is that it takes minimum time. To calculate the value of what? Range. It takes the minimum time to calculate the value of range. Now the next one is that it is particularly used or useful in statistical methods designed to maintain the quality of industrial products. That is the very best use of this range. Now let us see the demerits. Now the demerits are, the first one is that range is not based on all the observations. Of the data. As it needs only two observations, that is maximum and the minimum one. Now second, it is subject to fluctuations in sampling. In sampling means it may vary as the data varies. Now the next, it cannot tell, it is not able to tell. What does that? Cannot tell anything about, cannot tell us anything about the distribution of items or observations between two extreme values. Distribution about what? About the distribution of items. Distribution of items. It is not able to tell about the distribution of items. For example, range of 0, 50, 55, 53, 600 is same as the range of 0, 10, 25, 40, 75, 100. However, the variation patterns are different. What I say? 0, 50, 55, 53, 60 and 100. While the other series is what? 0, 10, 25, 40, 75 and 100. Now here if we calculate the range will be 100 minus 0. So 100. Here also range is 100 minus 0 is 100. So the range are same. But what about the other observations? These are different. So here the variation pattern is different. Still the range is what? Same. So it cannot tell about what? The distribution of items to us. Fine. We are unable to determine that one from that. Fine. Now next, it tends to increase with the size of the sample. Size of the sample. For this reason, the value of range cannot be interpreted without knowing the number of observations. So, it is not able to increase with the size of sample while it remains same. Fine. Now, let us see the applications of range. Applications of range. Now, as we say earlier that range is suitable measure of dispersion in case of small groups with less variation and useful in situations when one wants to know only the extent of extreme dispersion. Now, some more situations where the range is used. Now, let me try the situations directly. That are, suppose stock market reports stated in terms of their range, by quoting the high and low prices of stocks. Over a period. This is one of the best example for this. Now the weather reports are mentioned in terms of maximum and minimum. Temperatures. Okay. Then the next one, in statistical quality control. Statistical quality control. Since the same sample size is used repeatedly, the range is used as a measure of variation within the sample. Now the next one, in engineering and in medical reports, there also it is very useful. And medical reports, these are some situations in which the range is used. Most probably the range is used. Now let us see one small example on range to compute it. Now following are the prices. These are given in rupees of shares of a company. On 6 consecutive days. Now the question is that compute range and coefficient of range. These are the questions. Now what is the data? Now the observations are, the prices are 200, 210, 208, then 160, 220 and 250. Now if you look carefully the solution, what is solution? The range is what? The maximum minus what? Minimum. What is that? The maximum is what? 250. And if you look, the minimum is what? 160. So the range will be what? 90. And this is in rupees. So rupees. Now coefficient of range. What does that? The result is what? Maximum minus minimum upon maximum plus minimum. So what is here? 250 minus 160 upon 250 plus 160. So 250 minus 160 will be 90, and 250 upon plus 160 will be what? 410. So these are get cancelled. 9 upon 41 is nothing but 0.22. Fine. I take up to 2 decimal places. This is what? The coefficient of range. So as such, we can define range. We can write down its merits, demerits, the applications of it, and how to determine the range and the coefficient of range. This is about the range. Now here we will stop. Now in next video we will see the quartile deviation. Thank you.